What is the next heading, beta? Prism. Okay. What is a prism, beta? It is nothing but two plane surfaces inclined certain angle. Okay. If two refracting surfaces are inclined at an angle, then it is called prism. Okay. Like say, if two surfaces are inclined like this, plane surface, making an angle A, that will be your prism. Or say, for example, when a ray of light is being passed through a slab like this. Okay. And when a ray of light is being incident on this one, this will be the normal. It will get refract, bent towards the normal. And from here, if I'm taking again right now normal, it bends denser to rarer medium. It bends away from your normal part like this. Clear? Prism can be of any shape beta. Like say, for example, if this is a prism right now for me, this is also a prism. But provided there should be a certain angle between the two plane surfaces. That is only the condition for us. Am I clear? Let's see. If I talk about a triangular prism like this, okay, this will be the angle of your prism. That is nothing but A. When a ray of light is been incident on this one, this will be the normal. Rarer to denser. This is your angle of incidence I. It will bend towards the normal. Again, from here, if the ray of light is been incident on this one, denser to rarer, it bends away from the normal. Okay. If I take this ray of light, if prism would have been not present, this light might have been gone in a straight line like this. And the final refracted ray, this if I am extending in the backward direction, it is meeting somewhere here. The angle made by the incident with the refracted ray is known as right now for me deviation. Okay. This is your angle of refraction R1 and this is your angle of refraction R2. Okay. Angle of your prism. Now tell me what all the formulas you remembered in this one beta. Angle of prism is nothing but what? Angle made by the two refracting surface is known as of your angle of your prism. Am I clear? Am I clear?
Yes, sir.
Now see here if I am writing with respect to the normal angle of your refraction, this will be the angle of refraction. This is your angle of incidence. This is your angle of your emergence. So this will be equal to your R1 and this one will be equal to your R2. Clear? That is made up of your refractive index mu. Now tell me what all the formulas you remembered in this one. First one is how to calculate the deviation. Deviation formula dou is equals to angle of incidence plus angle of your emergence minus angle of your prism. Second one, R1 plus of your R2 must be equal to your A for small angles. Okay. So these are the formulas you need to remember this one. If I'm talking about for angle of minimum deviation, angle of minimum deviation, angle of minimum deviation, deviation represented by letter dou. Okay. For minimum deviation, angle of incidence must be equal to angle of emergence. And R1 must be equal to R2. That must be equal to your R. So at that time, R1 plus R2 plus A. So R plus R, 2R is equals to your A. So angle of refraction will be equal to how much for me? A by 2. For the minimum deviation, refraction angle will be equal to half the angle of your deviation. Minimum deviation formula button of dou minimum is equals to I plus E. What is the value of your I? Both of them are same. It is 2I minus of your A. Okay. So minimum deviation is equals to 2I minus of your A. Because from this one, I'm taking E is equals to your I. So deviation is equals to in the minimum deviation, dou minimum is equals to your 2I minus of your A. A is your angle of your prism. I is your angle of your incidence. If I'm talking about a refractive index, mu is equals to sine of your I divided by sine of your R. That is equals to your sine. I will be equal to how much for me beta? A plus minimum deviation divided by 2. Divided by Sine of R is equals to your how much for me here, beta? A by 2. So these are the some of the standard formulas you need to remember. Clear, beta? For minimum deviation, deviation is also given for me how much, beta? Dou is also equal to your mu minus 1 into your angle of your prism A. Okay. For minimum deviation, dou will be equal to how much for me? Mu minus 1 into your A part of relation. Am I clear?
Yes, sir.
This formula is very, very important, beta, for you. Mu is equals to refractive index of your prism is equals to your sine of your A plus D divided by 2 divided by sine of your A by 2. This is also called as of your prism formula, which you might have been even studied as if your essay important question for your board exams. Clear? Sure. Let me give you one small question. Do it faster. Like say for example, the angle of your minimum deviation, the angle of your minimum deviation measured with a prism, the angle of minimum deviation measured with a prism is like say for 30 degrees, and the angle of the prism, the angle of your prism is 60 degrees. Okay, the refractive index of the prism is mu of the prism is how much? Or try to do it faster. Dow minimum is given how much, beta? Minimum deviation is how much for me? 30 degrees. Angle of your prism 60 degrees. Need to calculate refractive index. Direct formula, mu is equals to your sine A plus of your D divided by 2 divided by sine of your A by 2. So that is equals to your sine. Angle of prism is right now for me 60 plus minimum deviation is 30 divided by 2 divided by sine. This is 60 divided by 2. Okay. So this value will be equal to sine. 60 plus 30, 90, 90 by 2 is nothing but 45. Sine 45 divided by sine 30 degrees. Isn't it? So that value will be equal to your 1 by root 2 divided by sine 30 is equals to 1 by 2. So it is a 2 by root 2. That is root 2. Am I clear? Am I clear? Sure. Next question.
Yes.
Now say for example, try to do it faster, better. The angle of incidence, the angle of incidence for a ray, for a ray of light at a refracting surface, at a refracting surface of your prism, is 45 degrees. Okay. The angle of prism, the angle of a prism is say for example 60 degrees. Okay. If the ray suffers minimum deviation, if the ray suffers minimum deviation through the prism, okay, the angle of minimum deviation, the angle of your minimum deviation and refractive index of material, and refractive index of material of prism is how much? Chalo, try to do it. I'm not doing it for you. Please try to do it out well. The angle of incidence for a ray of light at a refracting surface of the prism is 45 degrees. That means what? Angle of incidence is given for me 45 degrees. And angle of prism is how much for me? 60 degrees. Okay. He's asking me to calculate the minimum deviation. Dow minimum formula, beta. Minimum deviation is equals to 2i minus of your A. So it is a 2 into 45 minus 60. That will be equal to 90 minus 60. That will be equal to 30 degrees. Then I hope you can calculate the refractive index. Mu is equals to sine of your A plus D divided by 2 divided by sine of your A by 2. Use this one and tell me the answer.
Root 2.
How much?
Root 2.
Root 2. Got it, everyone?
Yes, sir. Root 2.
2. Okay, chal. Now, see, beta, if angle of prism is lesser than A is lesser than 10 degrees. If angle of prism is lesser than 10 degrees, then minimum deviation formula dow will be equal to dow minima. Then dow minima will be equal to how much for me? Mu minus 1 into your A. When to use this formula? When angle of prism is lesser than 10 degrees. Then you can use this formula mu minus 1 into your angle of your prism. Clear? See one question based on this formula. The angle of the glass, the angle of glass is 4.5 degree. Okay. And refractive index and your refractive index is 1.52. The angle of minimum deviation. The angle of minimum deviation is. Chalo, try to do it faster. Angle of glass. That means A. A is equals to 4.5. Mu is equals to 1.52. Is asking the deviation. Dow is equals to how much? As it is lesser than 10 degrees, I can use the deviation formula. Dow is equals to mu minus 1 into your A. 1.52 minus 1 into your 4.5. So this value will be equal to 0.52 multiplied by 4.5. So how much it is coming is
2.34.
so it is coming out for me how much? 2.234.
2.34.
Chalo. Got it? Chalo. Next one, an important area, that is your lens maker's formula. Can anyone tell me what is a lens maker's formula? For a lens which is a convex lens, central part is thin and outer part is thin. This is the radius of curvature R2. This is the radius of curvature R1. This is the refractive index of lens. This is the refractive index of medium. Let's say I have kept this lens in a medium. Okay. This color is representing that the lens is not in air, but it is in some medium. Okay. So now see here. Whenever the surface is like this, radius of curvature will be positive. If the radius is like this curvature, R will be your negative. Okay. Now see, if I'm talking about in medium, the focal length is given by the formula 1 by F is equals to refractive index of lens divided by refractive index of medium minus 1 into 1 by R1 minus 1 by R2. This is the formula. When it is in medium, 1 by F is equals to your refractive index of lens divided by refractive index of medium minus 1 into 1 by R1 minus 1 by R2. R1 and R2 are radius of curvature. Now, for example, if I'm talking about in air, refractive index of medium will become how much for me? 1. That means 1 by focal length in your air. This is focal length in medium. This value will become for me refractive index of lens minus 1 into this one is 1 by R1 minus of 1 by R2. I hope you remember this formulas. Okay. Now see, if I'm talking about the sign conventions. Sign conventions. All the distances are to be measured from the pole beta. This one is known as aperture. This one is known as of your principal axis. This diameter is known as what for me? Aperture. This one is known as what for me? Your principal axis. All the distances are to be measured from the pole. That is nothing but O. Okay. In this direction, we are taking positive. And in this direction, we are taking negative. Okay. Coordinates for this one are 0, comma 0. Am I clear? So
So
this is better.
can you admit 10 में?
Sure. Okay. Sign convention ढूंढना. Principal axis in the direction of light positive, opposite to direction of light negative. Okay. This will be the radius of curvature. This is your R1 and the radius of curvature of this one is right now for me R2. So convention here R1 will be equal to positive and R2 will be equal to your negative. Clear? Just now I told you, if the curvature is like this, radius of curvature will be taken as positive. If the curvature is like this, radius of curvature is taken as of your negative. Clear? So can I say here, for convex lens, focal length is positive.
watch के दो बस.
Okay? This will be equal to converging. Mute yourself better. Converging lens. So this will be the converging lens.
Convex lens.
Okay. Next one is right now for me concave lens. For concave lens, the focal length is negative. It is also called as what for me? Diverging lens. For diverging lens, central part is thin and the tapering part is thick. Okay. That was the condition. For convex lens, focal length is positive. For concave lens, focal length is negative. And convex lens is known as converging and concave lens is known as of your diverging. Am I clear? Sure. Let me give you a small question. See how many of you can do it out. If the lens is of this shape, this is your principal axis. Okay. Now, if I say that radius of curvature of this side is right now for me say 60 centimeter. Radius of this one is say for example 40 centimeter. That is made up of refractive index nu is equals to 5 by 3. And refractive index of your medium, it is in some medium, so it is your 4 by 3. Okay. Now I need to calculate the focal length. Focal length is equals to how much? It is in some medium. This lens is in your medium. Done? Tell me, what will be the focal length? First, tell me what are the radius of curvature. R1 is what beta, positive or negative? R1 is positive plus 60. R2 will be equal to how much beta? That is also positive or negative? Anyone? Chapala. R1 is positive or
Positive.
negative? Very good. Because I told you if the curvature is appearing to be this shape, you take it as positive blindly. Now don't bother about line convention at all. So it will be equal to your plus 40. Refractive index of lens is how much for me? 5 by 3. Refractive index of medium is how much for me? 4 by 3. So formula is 1 by f is equals to refractive index of lens divided by refractive index of medium minus 1 into 1 by R1 minus 1 by R2. Got it? So this will be equal to 1 by f is equals to length is right now for me 5 by 3 divided by medium is right now for me 4 by 3. This is minus 1 into 1 by R1 is 60 minus 1 by your 40. So this value will be equal to 1 by F. So this 3 will get cancelled. So it is 5 minus 1 divided by 4. So it will be equal to 5 minus 4 divided by 5. That is nothing but 4 LCM into 1 by 60 minus 1 by 30. That means the LCM will become how much for me? 1 by 20. So it will be 2 minus of your 3. So it is 1 by 4 here into this value will become how much for me beta? Minus of 1 divided by 120. So focal length will be equal to how much beta? Minus 4 divided by 120. So how much it will be? बताइए ना बेटा. Please mute yourself बेटा. ध्यान करना. So how much I'm getting with better? This is 1 by F, not 1F. Okay, this is 1 by F. So 1 by F is equals to minus of your 1 by 480. So focal length F will be equal to minus of 480 centimeters. आया सभी को? Am I clear with this one?
Sir, this much also focal length. This much.
It is in centimeters ना बेटा. 100 centimeters is equals to how much one? Lenses भी रह सकते हैं ना? Done? चलो. Will you do one more problem? So you try to do this one. Like say for example, this is your lens. Okay. And the refractive index of medium is 3 by 2. Refractive index of lens is 5 by 3. And this one is right now for me 30 centimeter. And this one is say for example 20 centimeter. This is in some medium again. Chalo. Find the focal length. Focal length is equals to how much? Can anyone try it out fastly? Tell me radius of curvature. R1 is how much? Plus 30 or minus 30? Plus 30. R2
Minus 20.
minus 20. Refractive index of lens 5 by 3. Refractive index of medium 3 by 2. And you know the formula? 1 by F is equals to refractive index of lens divided by refractive index of medium minus 1 into 1 by R1 minus 1 by R2. आप लोग को पेन चलाना है बेटा. मेरा पेन चलाने से कुछ नहीं होता. बैठ के सुनते रहते तो कुछ भी नहीं होता. That is equals to 5 by 3 minus 1 divided by 3 by 2 minus 1 into 1 by R1 is plus 30 minus this is 1 by minus 20. So it is 1 by F is equals to how much I'm getting this one beta? 5 2s are 10, 3 3s are 9, 10 by 9 minus 1 into 1 by 30 plus 1 by 20. Okay, so 1 by F is equals to 10 by 9 minus 1 is how much beta? 1 by 9 into इसका LCM कितना हो जाएगा? 60. This will be 2 plus 3. So it is 1 by 9 into 2 plus 3 is 5. 5 by 60. So that is equals to 1 by 9 into 1 by 12. This is 1 by F. So F is equals to how much for me? 12 nines are Hmm?
118.
How much? 12 nines are
108.
where? 108 centimeters. Clear? Am I clear, beta? Chalo. One more question, faster. This is a lens. Okay. And this is your air. This one is 30 centimeters. This one is 20 centimeters. This one is 3 by 2. Okay. Find the focal length. F is equals to how much? Chalo, try to do it. Tell me radius of curvature. R1 is equals to plus 30 centimeters. R2 is equals to minus 20 centimeters. Refractive index of lens is 3 by 2. Refractive index of medium is 1. Air cover. How much? 1 by F. Yeah, 3 by 2 divided by 1 minus 1 into 1. This is minus 20. So it is 1 by 2 here, isn't it? Into this one is again LCM 60. This will be 2 plus 3. So this will be 1 by 2 into 5 by 60. That is equals to 1 by 2 into 1 by 12. 12 to is a 24. So focal length will be equal to plus 24 centimeters. Done?
Yes, sir.
Chalo. Next one. Shireen, I beta up.
الله أكبر الله أكبر
Shireen, are you present? Shireen, yes, sir. Chalo. This is what type of a lens, beta? Convex lens. And here is, say, for example, water. Refractive index of medium is equals to 4 by 3. Refractive index of lens is equals to 3 by 2. This radius is 30 centimeters. This one is right now for me 20 centimeters. Find the focal length. Chalo, jaldi, fast. Tell me radius of curvature. R1 is equals to plus 30. R2 is equals to minus 20. See, a refractive index of lens is greater than refractive index of medium, isn't it? So 1 by focal length will be equal to, this is 3 by 2 divided by 4 by 3 minus 1 into 1 by 30 minus 20. So it is 3 is a 9. 9 divided by 8 minus 1 into LCM is 60. This is 2 plus 3. So 9 by 8 minus 1 by 8, this will be into 5 by 60. That is equals to 1 by 8 into 1 by 12. So 12 8 is a 96. So 1 by F is equals to 96. So focal length is equals to plus 96 centimeters. Done, beta?
Yes, sir.
Sure. One more question. Like say, for example, this is your lens. Refractive index of this one is 3 by 2. Medium is equals to 5 by 2. Radius of curvature here is 30. This radius of curvature is 20. Here the refractive index of medium is greater than refractive index of lens. Then what happens? See, whenever the refractive index, this point is very important. If lens is greater than medium, the focal length will come out for me positive. Now here medium is greater than lens. So focal length should come in the negative. Sometimes what happens is without much calculation, you can give me the answer. Isn't it? Focal length में अगर पूछ रहा है and you know this condition, Focal length of lens is greater than focal length of medium. If three options are in negative, one option is in positive. Now, without doing calculation, you can take that answer and come. So you'll save your time. Here
For
also
both
same.
lenses,
Huh?
for
What
both lenses,
for both lenses? No. This is for convex lens. Okay? Because we're talking about the converging lens. Now see here for this one. For this one, the focal length should 110% come in negative better. 1 by f will be equal to this is 3 by 2 divided by 5 by 2 minus 1 into 1 by r1. R1 is 30 minus of 20. So this will be equal to how much per moment?
minus 1 by 30.
Minus 1 by 30. So 3 by 2 divided by 5 by 2 minus 1. This is minus 2 by 5 into this value will be equal to 1 by 12. Just now we got the LCMs there previously. 1 by f. So this will be 2 ones are 2 6 are 5 6 are 30. So f will be equal to minus of 30 centimeters. Got it? Am I clear? Sure. Now see this condition. I'll write here. If diffractive index of lens is greater than the refractive index of medium. Okay. If lens is greater than medium beta on immersing in such liquid or in such medium, focal length of the lens will increase. Focal length of lens will increase. Okay. And I can say that nature of the lens will remain same. Nature of lens will remain same. That means if it is converging, it will remain converging. If it is diverging, it will remain for me diverging condition. The same way, if focal length of the lens is lesser than focal length of the medium, okay, in this case, nature of lens will change. Nature of lens will change. It is very important, beta. Like say, when you're immersing in a liquid, convex lens will behave like of your concave, and concave lens will behave like of your convex. So at the time, the focal length of this one is negative, and for convex lens, the focal length will be equal to your positive. Are you getting my point? If the refractive index of liquid is lens is lesser than the refractive index of medium, then the nature of lens will change. If the refractive index of the lens is greater than the refractive index of medium, the nature of the lens will remain for me same. Nature of lens will remain for me same. In this one, nature of lens will change. That is, converging will become diverging and diverging will become converging. Clear? Third condition. If refractive index of lens is exactly matching with the refractive index of the medium, then what will be the focal length beta? Focal length will become for me infinity. That means lens will vanish. Lens will vanish. Light will travel undeviated. Done? Sure. Next one. Power of lens. Next one is power of lens. Power of lens means देखो बेटा P is equals to 1 by reciprocal of the focal length in your meters. That is equals to your 100 divided by focal length in your centimeters. Unit is diopter represented by capital D. Okay. So unit is your diopter. Am I clear? Sure. Next one is combination of lenses. combination of lenses. When the lenses are in contact, better, n number of lenses are in contact, converging lenses. Like that, n number of lenses are in contact. Okay, this is f1, this is f2, this is f3, so on up to fn. Then power of your equivalent will be equal to your p1 plus p2 plus p3 plus so on up to pn. The same way focal length of your equivalent focal length will be equal to 1 by f1 plus 1 by f2 plus 1 by f3 plus so on up to 1 by your fn. Okay, the same way, if two lenses are separated by certain distance, like this, focal length of this one is f1, focal length of this one is f2, and they are separated by certain distance d. In that case, effective focal length 1 by f equivalent will be equal to 1 by f1 plus 1 by f2 minus d divided by f1 into f2. This will be the focal length. Effective focal length when they are separated by certain distance d. Clear? Sure. Give me the answer for this one faster. Let's say, for example, I got two convex lenses, of focal length 20 centimeter and 25 centimeter, and they are placed in contact. With each other. Okay. Then power of this combination is how much? Then power of this combination. Tell me faster. Power for the first one, when focal length is given, P1 is equals to 1 by F1. That is 100 divided by 20 because it is given in centimeters. So it will be equal to how much for me? 5 diopter. P2 is equals to 1 by F2. That is equals to 100 divided by 25. That will be equal to 4.
9.
So how much it will be? P equivalent will be equal to your P1 plus of your P2. That is 5 plus 4. Enta? 9 diopter.
9.
Done? Sure. Next question. Faster again. I got two lenses of power plus 2.5 diopter and minus 3.75 diopter. Again, they are combined. To form a compound lens. Okay. Its focal length is how much? Its focal length in centimeter will be how much? First option is 40 centimeter minus 40 centimeter minus 80 centimeter and 160 centimeter. So tell me the answer. Two lenses of powers are given for me. So P equivalent will be equal to P1 plus P2. So it is 2.5 plus minus of 3.75. So P equivalent will become how much for me, beta? Minus 1.25 diopter. So focal length will be equal to 1 by P equivalent. So it is your 100 divided by your P. So that will be equal to minus of 100 divided by 1.25. See how much I'm getting this. Centimeters, that is the reason I'm taking 100 there. How much beta?
Minus 80.
Minus
80.
80 centimeters. Clear?
Yes, sir.
Next question. मान के चलो, we got two thin convex lenses. Two thin convex lenses of focal length 10 centimeter and 15 centimeter, and they are separated by a distance of 10 centimeters. Then what is the focal length? Then focal length of combination is, chalo tell me, 4.2 centimeter, 6 centimeter, 10 centimeter, 15 centimeter. Chapal. Two thin convex lenses are separated. This is one convex lens. This is your another convex lens. Separated by distance of your D is equals to how much for me better? 10 centimeters. So 1 by F equivalent will be equal to how much? 1 by F1 plus 1 by F2 minus D divided by F1 into F2. So 1 by F equivalent is equals to 1 by F1 is 10 plus another one is right now for me 15 minus distance is 10 divided by this is 10 into your 15. So how much I'm getting right now? This one, this 10 will get cancelled. So this 1 by 15 and this 1 by 15 will get cancelled. So F equivalent will come out for me how much better? 10 centimeters. Okay, 10 centimeters will be the answer.
Yes, sir.
Am I clear?
That's it.
Sure. Next one, cutting of lenses. Cutting of lenses. Okay. Now I got a lens right now here like this. This is your principal axis. If I cut this lens into n number of pieces like this. Okay. So this one is right now for me 1, 2, 3, 4, 5, 6, 7, 8. Okay. If f naught is the original focal length, on cutting it parallel to the principal axis beta, the focal length will not change. Try to remember. Okay. If the red one is having a focal length of f naught, the fifth one, if I'm asking what is the focal length of this one, this is also right now how much for me? F naught. Clear? So what I can say, on cutting parallel to principal axis. This is your principal axis. Okay. So on cutting parallel to your principal axis, one thing is very clear, focal length will not change. Okay. Then focal length of each part will be equal to the original. Make sure of that one. Okay. Focal length of each part. Focal length of your each part will be equal to original. Clear? Then on cutting perpendicular to principal axis. On cutting perpendicular to principal axis. Like say this is your convex lens and having a focal length of your f naught. Okay. If this is cutted perpendicularly like this, they are called as what? Plano-convex lens. Plano-convex lens. Plane surface will have a radius of curvature infinity. Okay. And this will be your principal axis. That means you're cutting this one perpendicularly like this. Okay. So then each will have a focal length of your how much better? This will have a focal length of 2 times of f naught. And this one is also having 2 times of f naught. Because if I add them, again, I'll get back right now for me f naught. Clear? Am I clear? Sure. So that was about your second case. Now third one case. Like say for example, if I'm having a lens like this. and this one is principal axis. I have cutted this one into two parts here. This is having a refractive index mu1. Okay. This is having a refractive index of mu2. Then this is having one refractive index again right now for me, mu1. And this is having a refractive index of your mu3. This is one lens. This is your another lens. This one is again same lens, same material. Like this, the one which I have taken above. And down one is again different. So how many images will form it? Mu1, mu2, mu3. So 3 images. Any refractive index unte any images man, isn't it? So that means we are getting 3 different focus. 3 different focus. Okay, because we are getting 3 different refracting surfaces. So number of images is equals to number of images must be equal to number of refractive indexes. So we are having mu1, mu2, and mu3. That is the reason we are getting how many images, beta? 3 images. Am I clear? Now, if the lens is like this, it is closed. Like somewhere it is closed right now here. Somewhere here it is closed right now here. And somewhere it is closed here, right? What happened to this one bit? Focal length will remain same. F naught is equals to same, but intensity decreases. Intensity or brightness of the image will decrease. Am I clear? Am I clear, beta?
Yes, sir.
Sure. The next one is silvering of lenses. Silvering of your lenses. మనకు యాక్చువల్లీ లాంగ్ టర్మ్ ఉంటే చాలా డీటెయిల్ డెరివేషన్ పోతాం నాన్న, బట్ స్టిల్ వీఆర్ హ్యావింగ్ వెరీ స్మాల్ టైమ్. దట్ ఈస్ ద రీజన్ ఐఎమ్ జస్ట్ టాకింగ్ అబౌట్ ద నెక్టార్ విచ్ ఈస్ బీన్ ఇంపార్టెంట్ ఫర్ అస్ టు డూ ద న్యూమరికల్స్. Now say for example, this is your convex lens. Okay, and if it is silvered outer side, so the outer surface will act as of what beta? Mirror. If a ray of light is incident on this one like this, it undergoes refraction incident on this one, and from here it will reflect back incident on this one. Again it will go back like this. Am I clear? That means indirectly, if I make a free body diagram for this one, it is a combination of your one lens like this, and it is a combination of your mirror like this. So it is a combination of your lens. Am I clear?
Yes, sir.
So it is undergoing refraction by the lens 2 times. Reflection by mirror, then refraction by lens. See here, when a ray of light is incident, I'll write here process of light. Process of your light journey. Now tell me, first one, the ray will touch your lens. This is the lens, this is the mirror. So first one is, it undergoes the refraction by lens. Second step, it undergoes reflection. It undergoes the reflection by whom? By your mirror. Third one again right now for me, it undergoes a refraction by your lens. That means it is touching the lens 2 times and mirror 1 time. Am I clear? So when I'm writing the P effective or equivalent power, so it will first touch the lens, then it will touch the mirror, then it will touch the lens, isn't it? So that means P equivalent will be equal to 2 times of power of lens plus of your power of your mirror. P equivalent is equals to 2 times of your PL plus of your PM. And how do you calculate effective beta? 1 by effective focal length is equals to 2 times of the focal length of lens minus 1 by focal length of your mirror. Am I clear?
Yes,
Am I
sir.
clear? Why beta? Because see, focal length of your lens is 1 by focal length f in centimeters. Whereas for mirror, if I am writing for mirror, it is minus of 1 by focal length in your centimeters. That is the reason we got the negative. For mirror, it is negative. Whereas for the lens, it is your positive. Got it? Am I clear?
Yes, sir.
Sure. See this first problem there. Beta. A point object is moving on a principal axis of a concave mirror of focal length 24 centimeter. Okay, towards the mirror. When it is at a distance of 60 centimeter from the mirror, its velocity is 9 centimeter per second. What is the velocity of the image at that instant? I hope you remember the formula for this one. Velocity of image is equals to v square divided by u square into velocity of object, isn't it? Now, how do you calculate the image distance beta? V is equals to u into f divided by u minus of your f. Object distance is given for me. Focal length is given for me. So I'm getting the value of your v. Okay. Once we get the value of v, then substitute in the formula. Velocity of object is already given. Just simplify it, we'll get the velocity of your image. See that problem there, beta?
Sir, minus m square.
Which one better? Magnitude I'm taking. Na?
Yes, sir.
Mala chepistaను లేండి, don't bother. Done with that problem, beta? Let's see whether I'm having somewhere. No, there are no section B, beta. You need to do still even. Sure. You have done electrostatics once, na? Sure. In tomorrow's session of your class, we'll try to do the problems on prisms, refraction, and as well as of your lenses. Tomorrow we'll try to do some selected questions and highly expected models on this one. Then after that, we'll try to start with your optical instruments and your defects. Okay. Lens displacement and Newton's formulas are also there. We'll try to discuss that one after your optical instruments. Okay. So tomorrow
defects has been deleted.
is better.
Defects deleted.
No. For the optical instruments, we need to have some knowledge now. Simple microscope, compound microscope, नियर पॉइंट फार पॉइंट पढ़ेंगे ना अपन वहां पर अपने को बेसिक नॉलेज चाहिए तो जस्ट इंट्रोडक्शन पार्ट कर लेके then optical instruments will try to do in detail simple microscope, compound microscope, and as well as a few terrestrial microscopes.
Telescope.
Okay, no? But tomorrow one session will try to keep exclusively for the problems on your especially on the lenses, refraction, spherical surfaces, prisms, and plane surfaces refractions with the silvering concept. Okay. And day after tomorrow, we'll start with the optical instruments.
Okay, sir.
Chalo. Today, you try to start with your PYQs of this chapter, beta. At least 5 or 10 questions you try to do before you go to the bed from today's topic. Okay? Chalo. Bye, beta.
Thank you.